Do everything we've learned this unit in Unit 4, and tomorrow you're going to have a test. If you will turn to page 195 in your science book, here's what's going to happen. We're going to go over every question in this Unit 4 review. And you're going to be able to write the correct answer down or choose the correct answer in your science book. Tomorrow is your test. Your test questions are going to look a lot, hint, hint. Your test questions are going to look a lot like these questions we're going to go over today. This is an important lesson to write the answers down in your book. Hint, hint. If you want to make a good grade on the science test tomorrow, okay? So we're getting close to the end of the 9 weeks, and I know some of you need to boost your grade up a little bit. Here is a good chance to do it, okay? There was a lot of information covered in the science unit. So let's get started and go over it. We've done a lot of vocabulary. We've done vocabulary activities with each of these words. So here we go. Let's see if we can match the words with the definitions. Now, as I say the correct answer, please write it on the line so you'll know what the correct answer is so you can study for your test tomorrow, okay? Number 1, the number of sound vibrations in a unit of time. So think about a wave. How many waves are there? How much sound vibrations are there in a unit of time? Remember, we learned that was frequency. So write frequency on the line here. The number of sound vibrations in a unit of time is called frequency. All right. Got it? Number 2, a material that lets light pass through it is called what? Well, we learned a bunch of words about how light goes through objects, but the material that lets light pass through it, did you pick it? It's transparent, isn't it? Write it on the line here. A material that lets light pass through is transparent, like a window, like a lens on your glasses, like a clear glass cup you might drink out of, would be transparent. Number 3, a form of energy that moves in waves and can travel through space is called light, isn't it? Just like the light from the sun travels through space. Remember, we learned that sound waves cannot travel through space because they need a material to vibrate off of, like air or the particles in air, or they can travel through water, they can travel through solids. But light, light doesn't need any particles to bounce off of in its waves. Light can travel through space. It's an energy that moves in waves. Light is number 3. Number 4, a material that both absorbs some light and lets some light pass through. So it absorbs some, but it lets some pass through. It just lets some is the key word. That's translucent, right? Translucent on the line. Material that absorbs some light and lets some pass through is translucent. Be like frosted glass or a curtain at your window. Some light comes through, but some is blocked. Translucent. Number 5, a range of light rays organized by frequency and wavelength is called the what? It's that big word we learned about. It goes all the way from radio waves to gamma waves on the other end. It's the electromagnetic spectrum. Try to write all that on that little line. I don't think you can. Electromagnetic spectrum is the answer to number 5. So remember, light has different wavelengths. It has different amounts of frequency. When we looked at the electromagnetic spectrum, we looked at the small part of it. That's visible light. That's light that you and I can see. White light, it's made up of the colors of the rainbow, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. Then there's a lot of light that we can't see. Okay? So the organization of light waves, light rays by frequency and wavelength is called the electromagnetic spectrum. Number 6, the size of the vibrations of a sound wave. So think about a sound wave. They're compression waves. Okay. The sound waves, the size of the vibrations, the larger the vibration, the larger is its amplitude. Amplitude. The size of the vibration of a sound wave is its amplitude. Write that down. If we were looking at those transverse waves, the big waves, we looked at that. The amplitude is how high that wave is, the size of the vibration. Okay. Number 7 and 8, we're filling in the circle that best answers the question. So you can just fill these in. Number 7, which of these objects produces a sound with low volume and high pitch? What does it sound like? Does it sound like an ambulance siren? No, they're not low volume. They'll hurt your ears when they go by. They're loud. An air conditioner? No, it kind of hums. It's kind of a low pitch, low volume. A chick? Yeah, that's what it is. It's letter C. Chicks go beep, 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 beep. They have a low volume and a high pitch. A cow, it goes murr. It's got a low pitch. So 7 is C, a chick. Number 8, which of the following can be found in binoculars, photocopiers, cameras, DVD players? What did we see in our video the other day? What kind of things are inside of telescopes, let's say? Cameras have these. All these things have them. They have a lens, a lens. Binoculars are like telescopes. They have lenses that make things look close. Some telescopes use mirrors, didn't they? So the answer to number 8 is a lens. Okay, turn to page 196 in your book. I hope you're writing these down. It'll help you a lot on your test tomorrow. Don't be lazy today. Get that book and write these down. Number 9, Helena used a spring to model a wave. So this is those compression waves like we talked about with sound. The compression here, and then it's spread out like a slinky compression. Then it's spread out, okay? The question asks this: which of the following best describes the part of the wave indicated by the dotted line at the far right? So this one. Okay, so what part of the wave is this? Well, we see it's the part where it's spread out, right? Over here, the springs are all close together. But right here, it's spread out. So let's see which answer makes most sense. A vibration in a light wave? No, light waves look more like this down here. A crest in a transverse wave? No, this is a transverse wave and a crest is the top. An area where molecules come together in a compression wave? No, here's where they're pushed together. This is a compression wave. That's where they're pushed together. So an area where molecules spread apart in a compression wave. Yeah, they're spread apart here, right? See how the springs are, the little coils of the spring are really close together where they're compressed here? But here they're spread out. So number 9 is D. Number 10 says, Leon drew a diagram of a wave. Go to sneeze. Excuse me. Leon drew a diagram of a wave. What's the distance indicated by the arrows called? So remember, these are the crests, which that thing will quit popping up. And these little things are the ones at the bottom are the troughs. So crest and trough. So what's the measure called from one crest to another crest? Well, we learned that that's called B wavelength. So 10 is wavelength. When we're measuring from one crest to another crest, we are measuring wavelength. Okay. Number 11. Julio drew this picture of a light bulb. What concept best describes what Julio is trying to show with this picture? Well, we see this light bulb. We see these little lines going out in every direction in straight lines. It's because light travels in all directions, doesn't it? Do you think he's trying to show that? Let's read the answers and see which one makes sense. Light moves in waves that can travel through space. That's true, but does this diagram show that? No. Or a picture, rather. Visible light travels faster than anything else in the universe. That's true, but does the drawing show that? No. Visible light forms one section of the electromagnetic spectrum. That's true, but does it show it? No. Light spreads out in all directions, traveling in straight lines from its source. There we go. 11 is D. It spreads out in all directions. This is showing that, isn't it? The light is spreading out in all directions, going in straight lines from its source, which would be the light bulb, okay? All right, so number 11 is D. It shows light going in all directions from a bulb. Number 12. Look at the illustration below. So we've got two girls maybe getting ready for school in the morning. Which sentence best summarizes what is happening to light that is hitting the surface of the mirror? Okay, well, what do we learn about mirrors and light? We learned that we see our reflection, right? So mirrors reflect light. So let's see which answer goes with that. A, it is reflected in many new directions. Well, that talks about reflection, but if it's going in many directions, I don't think we're going to be able to see it like we see in a mirror. Do you? We might come back to that. I don't think that's right. It passes through the surface of the mirror. No, light doesn't pass through a mirror. It bounces off of it. So that's not right. We know it's not B. C, it's reflected back in the same direction from which it came. So this talks about reflection. That one seems to make more sense to me than A. We'll come back to C. So we're looking at A and C. It changes speed and bends slightly as it moves in a single new direction. That's refraction. The mirrors don't refract light. They reflect it. So A says it's reflected in many new directions. C says it's reflected back in the same direction. Well, now remember, a mirror is smooth and shiny. So it reflects it in the same direction from which it came. If it was a piece of aluminum foil that was crumpled, we looked at that example in one of our lessons, it might reflect the light, but it would reflect it in a lot of directions. And so you couldn't see your reflection in a piece of crumpled aluminum foil very well. Surely not as well as you could in a mirror. So this answer to number 12 is C. It's reflected back in the same direction from where it came. So it's directed off of her nose right back to her face. That's why we can see herself straight across from where we are. Go ahead and turn to page 197 in your book. Well, this one looks a little complicated, doesn't it? 13 says, Farida, that's a complicated name, Farida drew this diagram of the electromagnetic spectrum. Well, we just on the previous page, two pages ago, looked at what electromagnetic spectrum is. So this one says, which statement is the best summary of all the information shown in the diagram of the electromagnetic spectrum? And so even though this is kind of hard to understand, it's got frequency, it's got wavelength, it goes from radio waves all the way to gamma rays. Okay, so we're seeing which is the best summary of what an electromagnetic spectrum is. We've already answered this, so it should be like our answer there on the first part of this test. It shows the colors of the rainbow arranged by hue. No, that's not what electromagnetic spectrum is. It shows the wavelengths of visible light in relation to those of radio waves. Well, there's a lot more than visible light in radio waves, isn't there? So it's more than that. It shows a range of light waves arranged by wavelength and frequency. There our answer is wavelength and frequency of different kinds of light waves. So the answer to 13 would be C. We'll read D just to make sure. It shows a range of objects and devices arranged by the decibel level of the sounds they produce. No. Electromagnetic spectrum is about light, not sound. So the correct answer is C. Number 14. Which feature makes laser light different from light from a light bulb? Well, if we just think about a light bulb, that picture we looked at a minute ago, it goes out in all directions. When we think about a laser pointer, it doesn't go in all directions. It goes in one single direction, doesn't it? So just think about what you know, and let's see which one of these makes sense. Laser light contains only long infrared waves. That doesn't make sense to me. I don't think that's the answer. Laser light contains an infinite number of wavelengths. No. Laser light shines in all directions. I already know that's not right. It goes in one direction. D, laser light contains one wavelength and is focused in one direction. That is correct. The correct answer is 14 is D. One wavelength. That's why lasers are a certain color. Depends on what wavelength it is to what color you get. And it travels in one direction. That's why you can point it at one spot on the wall and just see it right there, but nowhere else. It's only traveling in one direction. It's only one wavelength. That's what we've learned about lasers. Number 15. While swimming underwater in a pool, Xavion hears the honking of a truck's horn. Can you hear under the water? Sure you can. What happened as the sound waves traveled from the horn to Xavion's ears? Now this one's a bit tricky. Let's talk through this. The waves stopped when they reached the water. No. If he's underwater and he hears the horn, the waves didn't stop, did they? They came through the water. So we know it's not A. The waves sped up when they passed from the air to the water. What do you think? Did they speed up? Or did they? The next one says they slowed down when they passed from the air to the water. D says they didn't change speed. Well, we've seen with light that when light goes from air into water, it changes speeds. And it doesn't stop. So I'm going to know A and D are not correct. So we're looking at B and C. But now remember, we're not looking at light. We're thinking about sound. And so there's two different properties there you have to remember. Light doesn't need anything to go through. It doesn't need particles of air or particles of water to travel through. It would go anyway. And when that light is going through air, and then it hits the water, it slows down, and that's what causes refraction. But the difference in sound waves and light waves is that sound waves need something to bounce off of. And so sound waves, if you'll remember with me, as they're coming through the air, there's particles in the air that they bounce off of and travel through, but those particles are more spread out in the air. But in water, there's more, those particles are closer together. That's why it's like water is thicker than air, right? The particles are closer together. So if sound waves have to go from this particle to this particle to this particle, they're bouncing off particles that are more spread out. And then when they hit those particles in the water that are closer together, sound, we learned this, sound actually travels faster through water than it does the air. It's hard for us to imagine, but it's a true fact of science. We did one of those little lessons, those little digital lessons, and we looked at an experiment about that. So the correct answer 15 is going to be that the waves sped up when they passed from the air to the water because they're going to travel in the water faster. So that's the answer. 15 is B. 16. Look at this picture. Which word best describes the material used to make the lampshade? And the lampshade is this part around the bulb right there, okay? So do you see any light coming through the lampshade? No, it's stopping the light from coming through this lampshade. It's going straight, it's pointing it straight down. So something that does not allow light to pass through it is called what? Do you remember? It's called A, opaque. Opaque. Well, we've learned a lot, haven't we? Let's go to page 198. And we've got some little discussion things here we can talk about. 17 says, this picture shows Raj doing homework at his desk. There are several sounds being produced nearby. Use details about how sound waves travel. Explain why Raj may have a hard time concentrating and what he might do to improve the situation. Well, notice his desk is pressed up against this wall, and somebody's over here banging nails into the wall with a TV or a radio playing and a dog barking. And those sound waves, remember, they travel through air okay, they travel through water faster, and they travel through solids the fastest. And so it's going to be traveling through. We can see it coming through the wall. Sound can travel through solids. Light wouldn't. That wall would be opaque to light. It would stop light waves, but it does not stop sound waves. So Roger's going to have a hard time concentrating because sound waves are traveling through the solids. What might he do to improve the situation? Well, he could go to a different room where all this noise isn't happening. He could put some earplugs in maybe to block the sound too. 18. The diagram shows two types of lenses. Identify the two types of lenses showed below and tell how each bends light. Now, here's my clue to you on this. You see how this kind of curves in? Okay, that's a concave lens, like you're walking into a cave. Imagine like the curved part is a cave, the door entrance to a cave. So that's a concave lens. So we'll start with lens B just because I can remember that easily. Lens B is a concave lens. And what do concave lenses do? Well, the light comes in this direction, then it spreads it out. So concave lenses spreads light out. The other type of lens is lens A. It's called a convex lens. It's fat on the outside. And the light comes in and it's directed to a focal point. It bends light or turns light inward. So the concave lens spreads light outward and the convex lens spreads light inward. Okay. Number 19. If you place a straw in a clear glass of water, how will the straw look? Give a description of the straw in the water and explain why it has this appearance. Well, if we've learned that, that's refraction, right? It's going to look bent. So because the straw is in the water, part of it's in the water and part of it's out. The part that's in the water, as the light travels through the water, it slows down, the light waves do, and it makes that straw look bent. We saw that in the little video with the little magic guy and his magic wand before we saw the telescope video. That is called refraction. Now, look at our next unit. We're going to get into some animal science, so that'll be fun. But we better finish focusing on this first. So listen, guys, your test tomorrow, I hope you listened today. I hope you wrote these things down and weren't lazy. Your test tomorrow is going to look a lot like these questions that we've gone through. I really want you to make a good grade on it. We've learned so much, so many interesting things about sound and light in this unit. So study, take a look at these answers we've written down together today. Don't just throw your book away and not worry about it anymore, but go over it, review it. Remember what we talked about in social studies? Fourth grade is really different. You have to start studying for your test. So study what we've written down. The questions are not going to be exactly the same, but they're going to be very close. So if you know the questions from this Unit 4 review, you should do really, really well on the test tomorrow. All right. I hope you do great tomorrow in your test. Can't wait to see your good grades. See you later.